All right, in this presentation, I'm going to demonstrate how to do frequency tables as well as frequency distributions in SPSS using the menu options. So let's say we wanted to know how many women there are in our data set. We see here in row 4, the name of that variable is gender. So how to run a frequency table for gender, we go up here to Analyze, Descriptive Statistics, and then Frequencies. This menu will pop up and all of our variables are listed here to the left. We'll select gender because that's what we care about right here, and we'll move it over using this arrow to the variables column. Note that your output, really nice on these frequency distributions, SPSS will produce output that's in APA format or just regular output format. I'll leave it in the regular output format right now, but this is a really nice feature for running analyses that you're going to be producing for journal articles or academic purposes. All right, anyways, so we got our gender, we hit OK, and that pulls up our output. So what does this output tell us? First of all, it tells us that there are 985 cases in the data set where we know what their gender is, and 15 of our cases are missing information on gender. So we don't know if they're male, female, what have you. But here then, our next table tells us, all right, here's the breakdown. So of these valid cases as well, we see that 468 are males and 517 are females. Then we can also come over here, and these percentage columns are really helpful as well. So this first column tells us, even including the missing data, how many cases were in each, or what percentage of each category is makes up the total. So we know that of the overall data set, even including the missing cases, females comprise 51.7%. But if we ignore the missing, and that's what this valid percentage column is, that tells us that 53% really of the cases we know of gender, those are women. So frequency tables are useful for variables that are measured on either nominal or ordinal scales. They're not as useful for continuous variables. For instance, let's say I'm like, okay, I'm interested in the distribution of GPA in my data set. So I'm going to come up here and I come to descriptive statistics again. I'm going to remove gender and I'm going to say, all right, I'm interested in GPA. So let's see what that looks like. As you can see here from my output, this is a huge table that doesn't really tell me too much, honestly, unless I wanted to know exactly how many people had a specific GPA, like 3.48. But overall, this doesn't really tell me how across my entire data set, how sort of GPA is distributed. For that, we need to go to create a graph. All right, so rather than using frequency tables for continuous variables, graphs are better ways to sort of explore what your data are looking like. So SPSS has a number of ways to graph, but I'm going to show you through the graphs menu. So a histogram is a pretty common approach to understanding the distributions of continuous variables. So to do a histogram, you can go up here, click on graphs, go down to the histogram option, click on that, and it will pull up this menu set of options. And all you need to do is choose your variable that you want to graph. Here we want GPA last semester, move it over, and then hit OK. And this pulls up our results. So here is our histogram. And so what does this histogram tell us? It tells us kind of a lot, just looking at the shape of the graph, right? And this is really important when we get into more complex analyses like regressions in terms of understanding the shapes of each of our individual variables, because sometimes we transform them to make them a little bit sort of our results more precise or more reliable. But we're not going to get to that yet. So here, looking just here now at this distribution, it looks maybe a little bit bimodal, right? So bimodal is when there are sort of multiple peaks in our graph. So we seem to have sort of a mode right here around the most often reported amount, right around here, like at 2.7 or 2.6 maybe. And then again up here above 3.0, maybe around 3.3, right? So a little bit of a bimodal distribution. We also want to look at sort of the overall shape in terms of on the tails. And you can see here, this distribution is a bit skewed, right? We read about the skew, the idea of skew. That essentially means that it's not this perfect sort of normal curve. And in this case, there's more cases here on the right side, and sort of we have a bigger tail over here on the left side. So when you have a more pronounced tail on the left side, that means it's a negative skew. So a bigger left skew, or left skewed, I guess. It's where the tail is more pronounced. And most values are found on the right side of the mean, which we'll get into more in a little bit, when we have a negatively skewed distribution. So basically, we have more students in our data set who have sort of the highest possible GPAs compared to lower GPAs, right? So here, this is kind of a nice graphical illustration of what GPA looks like, and much easier to sort of understand the distribution of this variable rather than using a frequency table. Okay, a final menu sort of set that's really useful when you're exploring your data set can be found through the Analyze menu. So up here, Analyze, and then down to Descriptive Statistics, and then click on Explore. So this menu option gives you a lot of sort of nice tests again for continuous variables to look at their overall distributions and how close they get to normality. So we only have a few scale variables in this data set. This isn't as useful for ordinal variables or nominal variables, but for continuous variables, it's really useful. So let's look at GPA. So let's select GPA. We'll put it in our dependent list. Okay. So what I want you also to do is first go to the statistics link. The statistics link gives you a lot of really helpful commands. At this point, I'm not gonna go through all of them, but I'd like you to check the outliers blocks. So it automatically defaults to descriptive statistics, but then I'd also like you to click on outliers, then continue. And then there's this plots option as well. And the default there is stem and leaf plots. So stem and leaf plots are really useful, at least I think, and the author of our exploratory data analysis SAGE book also agrees that stem and leaves are useful. And you can also actually do a histogram tier too if you want, whatever. But okay, so make sure that your stem and leaf though is checked, continue, and then what I would like you to do is click on OK. Okay, now this pulls up a lot of output, which is really great. So first of all, it tells us at the top something to point out, the overall number of cases, but then also the number of cases that we're missing. So we only had 8 people whose GPAs were not part of our data set, so not bad there. Then we come down here, we have some descriptive statistics. We'll start talking about those even more next week. But one thing that I would point out is that it's also useful. It tells you, the lowest value for this variable, which the lowest GPA in our data set was 1.65, the highest maximum 4.0, and then the range, so the difference rate between these two, so how sort of spread out those values were. It also gives us a few other statistics, including skewness and kurtosis, which are really useful as well if we're going to report those data in a report as opposed to just including, a picture of our graph. All right, so this next table is really great. This is what is produced when you click on that outlier option. So it tells us what the highest and the lowest values were for our different, in our data set for GPA, and exactly which case that was. So that's really helpful. Let's say if you're like, hey, something's kind of whack, you can actually go back to your data set, right? Oops. So we know, all right, case number 983 and 984, 985. I don't know what's going on here with my screen. All right, here we go. We can go back to our data view and we can actually find, all right, here, case number 9 is the 1.65 GPA, right? And we can go over here to our table. They told us that. I actually had my data set sorted by GPA, so I kind of cheated. But you can see, like, okay, then if you want to go back into your data set and say, oh, maybe, I want to remove these cases, something weird happened, whatever, you can go use this to help kind of clean your data set and figure out whether or not you want to kind of remove some cases if maybe they lied. Like, let's say they said their GPA was like 8.4, and you know that that's not possible in the scale of the GPA at your university, then you could go in and either make it missing or discard that case, whatever you think is sort of the most appropriate way to handle it. So anyways, this is a really useful way to look at continuous variables, because again, I mean, you could come into your data set and sort it by sort each variable really easily in your data set by value. So you just go to your data set, you click on the actual column for your variable, and then you right click and you can just go to sort ascending. So I already have it sorted ascending, or sort descending. So that would put the 4.0s at the top, right? But now my outliers this won't be very helpful since now the case number has changed. But anyways, but this is really, again, useful for when you're going through your data set and cleaning it up and making sure that it looks like what you think it should look like. This is sort of a useful table, the outliers table, to sort of analyze. All right, now down here to our stem and leaf plot. So when you're also exploring your data, stem and leaf plots can be useful. I actually really like them, even though they look kind of weird. So here's the stem and leaf plot for GPA. So how do we interpret this? Basically, the stem are the first 2 values of our GPA, and the leaves are the third value. So essentially, somebody with a 1.65 GPA, here we go, we got our guy with our 1.65, so it's 1.6, and then the leaf is 5. And we can see here, so we have 2 cases that had 1.7s. One of them was 1.75, one was 1.78. So let's go through here. There were 78 people who had a 3.0 something, right? 78, so 3.00000, 3.1. There were 1, 2, 3, 4, 5. I don't know. My eyes are terrible. 1, 2, 3, 4, 5 people with 3.1s. And then, so this is, again, really helpful in terms of seeing how your data are distributed. So there are 2 advantages to stem and leaf over histograms. The first is kind of old school now. SPSS does this for us, but stem and leaves are much easier to construct by hand than histograms are. So that's one advantage if you have to do your data analysis by hand, but we don't. So though, I also like the stem and leaf because, the bars of a histogram can kind of hide the distance between different points. And so stem and leaf is really nice because it sort of gives you a more detailed understanding of the shape of your distribution and its relative height. And finally, SPSS will also give us a box and whisker plot. So the box and whisker plot essentially gives you kind of more detail about the tails or your extreme values. So how do we interpret this? Okay, so this box right here, this middle line right here, 3.0, is the median in our data set. And we'll talk a little bit more about means, medians, and modes next week, but this is our median. And then within sort of this box itself, this is half of our cases, basically. So half of the cases are in the box, and then a quarter of them are here, and the other quarter of them are here. And then our highest value or lowest value is marked at the bottom. So 1.65, you'll remember, was our lowest value, and our top value is 4.0. So a quarter of the cases, right? You can see it is a little bit non-normally distributed. Sort of, again, we have our skew, which we talked about before when we were looking at the histogram. This is kind of illustrated here because it's longer, right? This line is longer than this line right here. So a quarter of the cases are between about 3.6 probably 3.3 and 4.0, but then a quarter now on the bottom are down here between, let's say, about 2.55 and 1.65. So you can kind of get a better idea too, again, about sort of spread, particularly the tails of the distribution. And box and whiskers compared to stem and leaf. Stem and leaf doesn't show us, in the same way how the tail, it shows us how the tail sort of is distributed, but it's a different kind of illustration with the box and whisker plot. So they're particularly, again, valuable for identifying characteristics of distribution when the tails are deviating from our normal distribution, right? Our nice normal curve, bell curve of the data. Okay, so these are some very basic commands or menu options that you should use to sort of start familiarizing yourself with your data set, with the different variables in the data set and with their distributions, and understanding kind of what you're working with. And so just as a reminder, usually frequency tables are better for variables that are measured on either nominal or ordinal scales. And then for continuous variables, GPA, income, SAT scores, what have you, those are usually better explored with graphical measures. So what I'd like you to do is keep playing around with these different frequencies commands. And based on your analysis, I want you to really think about what these data are saying just in terms of frequencies. What are these data telling us related to Ethiopian students' experiences with digital learning?